All right, we're going to be talking about analyzing data. So we're going to start off by talking about measures of central tendency. So that's your mean, median, and mode. The mean is what we would call the average. So it's the sum of the data values over the number of values. This symbol here represents the mean. Okay, so remember that when we get into standard deviation. So the median is essentially the middle value. So it's the middle value on an odd set of data values, and it's the mean of the two middle values on an even set of data values. And then the mode is the most frequently occurring value or values. There can be multiple modes in there. So our first example here is we're going to be talking about job offers and how many students were offered these jobs. So the frequency table shows the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. What are the mean, median, and mode for the job offers per student? So the first thing we're going to look at is the mean. So here we have a bimodal set of data. Bimodal just meaning two modes, okay? So we have the job offers, and then we have the students. Now we can take this information and we can actually put it in a linear string of information here. And we will use this to find our median and mode. So when we're looking at our mean, what we can do is take the product of the number of students times how many job offers they have. So I would go 2 times 0 plus 2 times 1 plus 4 times 2 plus 5 times 3 plus 2 times 4, all over how many students there were. So I'm going to add up all these values here for students, 2 plus 2 plus 4 plus 5 plus 2. Now when I multiply that out, here I get 0 plus 2 plus 8 plus 15 plus 8, all over 15, which gives me 33 over 15. If I divide that 33 by 15, I get 2.2. So there's my mean, okay? So I'm going to put that symbol there. There's my mean is 2.2. So now we're going to look at median. Now with median, it is very important that we understand that our data has to be in order, okay? So it can't be jumbled up. It has to be in numeric order from smallest to largest. So what we're going to do is we're going to look here. I know I have 15 numbers. So halfway 15 is I'm going to have 7 on one side, 7 on the other side. I want to find the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. There should be 7 on this side. 1, 2, 3, 4, 5, 6, 7. So our median is 2. It's the middle of our value. Now we look here and we look at mode. Mode is our most common. So if we look here, how many times does, and then this is a nice table to show us our mode right away. We know that since there's 5 students here, our mode is 3. So that gives us our mean, median, and mode. The next part that we're going to be talking about is outliers. Well, what is an outlier? An outlier is a value that is substantially different from the other values. An example of that would be the age of the kindergarten class and the age of the teacher. The teacher would be an outlier because most kindergarten students are going to be 5 or 6 years old. The teacher is going to be older than that. Okay, so that would be an outlier. Okay, there is a formula to determine outliers, but it's typically, a lot of times you can just visually see it. It is the largest piece largest number out there, or the smallest. Okay, so if I have here these numbers, 56, 65, 73, 59, 98, 65, and 59, we can look at that information there and determine the outlier. Okay? Most of those numbers are situated around 50s and 60s, mid-50s, up to 60s. We do have a 73 here, but it's a low 70, and then we have 98. 98 would be my outlier because it is significantly higher than the other ones. Okay. So the last thing we're going to look at is we're going to look at a box and whisker plot. And this box and whisker plot is going to break items up into what we call quartiles. Okay, so a quartile just means that we're breaking our data up into 25%, 25%, 25%, and 25%. So we'll have our bottom 25%. This is where they end up with percentile ranks. So if you tested better than 75 percentile, that means that 75% tested below what you tested at. Okay, so if we look at a box and whisker plot, so what we're going to do is we're going to take some information here. So let's go 0, 1, or 2, 5, 5, 7, 8, 9, 10, 12. Let's see, 2, 4, 6, 8. Let's do one more so we can work on a median of an average. And let's put this as 13. So there's our information. So what we're going to do is we're going to look at a box and whisker plot here. And in fact, so what we want to do is we want to first find that median. So 2, 4, 6, 8, 10 pieces of information. So right here, half of our data is below it, half of our data is above it. So what we're going to do is we're going to find the mean between 7 and 8. And so that gives me 7.5. So I'm going to come here, I'm going to draw a bar here. This is at 7.5. Okay. Now what I'm going to do is I'm going to find the median of my bottom part of my data here. So there's 5 pieces of data here. Okay, so that means 2 on the bottom, 2 on the left. There's my bottom piece there. Okay, so notice that these are both 5s. So I'm going to have another line here. This is going to be 5. And there's my first box. Now my whisker is going to extend out. And a lot of times it's just our bottom number. And we'll kind of talk about outliers in a little bit with this. But we're going to kind of extend it to that bottom piece that is not an outlier. Okay. So now I'm going to do the same part for the top. I'm going to look here. There's my median of my top information. So I'm going to come out here, create a box. This is 10. I'm going to extend out my whisker to 13. Now that's a box and whisker. Okay. So now let's say I'm going to change that 13 to be an outlier. Okay. So I'm going to change this to be 56. So 56 is a substantial outlier. So what I'm going to do is now what's going to happen is my whisker is going to extend out to my value here that's still within, that's not an outlier. I'm going to put a dot out here that would say 56, and there's my box and whisker. Thanks for watching. That's data analysis.